In this episode, I am going to show you an example that performing matrix addition using two-dimensional array. So first we have to read the two matrices. So for reading the matrices, we have to know the order of the matrix. Order means the number of rows and number of columns of each matrices. So we have to declare some variables which are representing the number of rows and number of columns of the matrices. So here I am going to declare some variables r1 c1 and r2 c2. All are integers. So r1 is used to representing the first matrix number of rows, c1 representing the first matrix number of columns, r2 representing the second matrix number of rows, and c2 representing the second matrix number of columns. Okay, now we have to ask the user to enter the first matrix number of rows and number of columns. So use the printf function, enter number of rows of first matrix. So now the user enter some numbers, so we have to save that numbers into variable r1. So using scanf function, %d, ampersand r1. Okay, now we have to ask the user to enter the second matrix, enter the number of columns of the first matrix. So I copy this printf statement. Okay, enter number of columns of first matrix. So user enter a value, and here we are going to save it into variable c1. Okay, now we have to ask the order of the second matrix. So enter number of rows of second matrix, and user enter some value. Here we are going to save that values into variable r2, and enter number of columns of second matrix and save that values into variable c2. Okay, now we read the order of the two matrices. So before going to add two matrices, we have to check the number of rows of first matrix is equal to number of rows of second matrix, and the number of columns of the first matrix is equal to number of columns of second matrix. That means we have to ensure that the two matrices are of same order. For that we have to use an if loop. So here I use an if loop. If r1 equal to r2, that means the number of rows of the first matrix is equal to number of rows of second matrix, and the number of columns of the first matrix is equal to number of columns of second matrix. Okay, if these two conditions are true, we have to read the matrix and perform the addition. Otherwise, we have to show some message. Printf addition is not possible. Okay, so if user enter two matrices of same order, then we have to read the matrix. So first we have to read the first matrix. So for reading the two matrices, we need two-dimensional array. Also we have to save the result, so we need three two-dimensional arrays. So first here I am going to declare the first two-dimensional array. So int m1 of order. Here if this condition is true, r1 is equal to r2, so you can r1 or r2. So I put r1, and the column is c1 or c2. You can use anything because r1, r2, c1, c2 all are same. And this is the first matrix declaration, and we have to declare the second matrix. I name it as R2. You can use R1 or R2 and C2. Okay. Now the result matrix is or R is of the same order, so I declare another variable, another two-dimensional array with the same order R2. You can see use C1 or C2. I use C2. Okay. So now we declare three two-dimensional arrays M1, M2 and R. M1 for reading the first matrix, M2 for reading the second matrix, and R is the two-dimensional array used to save the result. Okay, so now we have to read the first matrix. So ask the user to enter the first matrix. Printf enter first matrix. So now user enter the first matrix. Okay, so for reading the matrix we have to start some nested loops. For that we have to declare some more variables I and j. Okay, so here I am going to initialize the first loop I equal to 0 and I less than the first outer loop representing the row operation and inner loop representing the column operation. So I less than R1 and I plus plus. Now here is the loop body, and now we have to read each row using the inner loop for j equal to 0 and the value of j less than C1 and C++. Okay, now we have to read the matrix using scanf function. So scanf %d and now use the address operator and read into first matrix M1 I j. Okay, this will read the first matrix, and now we have to read the second matrix. So I copy the entire statements, and now we have to read the second matrix. Enter second matrix. There is no need to change this into R2 because R1 and R2 are same, but here I change it into R2 and C2. And instead of M1, here we have to read the second matrix into second variable M2. Okay, so now we read the first matrix and second matrix. Now we have to perform the matrix addition. So for performing matrix addition we need the same nested loop. So I copy the nested loop. So here we have to save the result into matrix R. So R of ij equal to M1 of ij plus second matrix M2 of ij Okay, we add each element from the two matrices and save that the result into the third matrix. The resultant matrix R. Okay, so finally we have to display the result. So printf resultant matrix So for displaying the matrix we need the same nested loop. So I copy the nested loop, and here you have to display the matrix using printf function. Printf %d and display each element from the matrix R. So R of ij Okay, we need a space between every element, so put a slash t. So after printing the first row, after printing each row, we need a new line. So here I print a new line. Okay, thus we complete the coding. Okay, I will explain it once more. First, I read the order of the two matrix. The first matrix row is read into variable r1, and the number of columns in c1, and the second matrix order is r2 and c2. And first here I check the condition r1 is r2 and c1 is c2, because we have to ensure that the two matrices are of same order for performing the addition. If it is not true, it will just print out this message, addition is not possible. And if the condition is satisfies, that means the two matrices are of same order, we have to read the first matrix. So before going to read, I declare three arrays. The first two arrays is for reading the two matrices, and final one is for saving the result. Now here read the first matrix. So for reading the matrices, we have to use a nested for loop. So here I read the first matrix m1 using a nested for loop. Now read the second matrix is m2 using nested for loop, and finally I save the result into, I add each element of matrix m1 and m2 and save the result into the resultant matrix R using a nested for loop, and finally we print the result again using some nested for loop. Okay, now we can compile the program. So I compile the program. There are some mistake, there are some undeclared variable. It is not C, it is J. Okay, compile the program again. Yeah, here also the same mistake, J. You have to check it again. Yeah, here also it is not J, it is also J. Okay, I correct the mistake and now execute, compile it again. Now the compilation is success. Now I'm going to run the program. Okay, enter the number of rows of first matrix. Here I'm going to put 3. Enter the number of columns of first matrix. I put 1. Enter number of rows of second matrix 6. Enter number of columns of second matrix 2. Addition is not possible because here the order is not the same. So I'm going to run the application again. So now I'm going to add a 3 by 3 matrix. So enter the number of rows of first matrix is 3. Enter the number of columns of first matrix, again 3. Now enter number of rows of second matrix 3. Number of columns of second matrix 3. Now you have to enter the first matrix. So the first matrix is 4, 5, 6, 3, 7, 2. So this is one more row, 3, 7, 2. So this is a 3 by 3 matrix, the matrix that contains 3 rows and 3 columns. Okay, now we have to enter the second matrix, 2, 5, 1, 2, 5, 6. Now 2, second element 8. Now the third element 8. Now 4, 2, 5. Okay, this is also a 3 by 3 matrix. So now we enter two matrices of order 3 by 3. Okay, now here we got the output resultant matrix 6 plus 2, 4 plus 2, 6, 5 plus 5, 10, 6 plus 6, 12. We got the result. I hope you enjoyed this video. Thank you for watching. See you in the next part.